Hi everyone, my name is Bonaventure from EMS Technologies. You're welcome to the second edition of our broadcast coverage study. Like already know, if you've watched the first video, we are using Nortel's RF2 kit for this. To access that, go to support.nortel.com, click RF2 kit, and it will get you here. Meanwhile, you have to create an account first, like we mentioned in the first video, and then log in. I've already logged in, so I'll just click RF2 kit. So it takes us to where we will start our coverage study. Meanwhile, it's important to watch our first video because we are just going to jump straight to what we are doing today. Today, by the way, we are going to treat how to do a point-to-point coverage study. In our first video, we did how to do a general coverage study. Depending on your antenna height, antenna gains, and your transmitter power, you can find out the places your signals will be able to get to. You understand? But today, we are dealing in just point-to-point coverage study. So you know if you have a line of sight, if your transmitter power will be able to get to your second site. At this point, it's good you go back to watch the first video. If you have not done so, go to YouTube and search for broadcast coverage study. You should have that as number one there. Watch it because we've covered most of the things here. It's just about 30 minutes approximately. So do that before coming over to this second video. Thank you. So let's go back here. Once you are here, click on radio coverage 2. We'll move quickly so we can round up quickly. We're just going to go to new point-to-point link. Point-to-point link usually comes up when your transmitter site is away from your studio, where you then need an STL link to take your studio signal to your transmitter so it can be broadcast. To do that, you need to have created the transmitter site, which we did in our first video. Now, we'll then create a site to assume is our studio, which is where the transmitter of STL equipment will be mounted. The receiver will be at the transmitting station. Now, I will use a site I've created in the past as a studio site, and then we will use the transmitter site created in the first video as our transmitter site, of course. So here we go. Remember also that depending on the power of your STL equipment, you have to be mindful of the distance because a certain STL transmitter power covers a certain range or distance. So this is also part of what this tool is going to be telling you. You understand? First, whether the power is going to cover the distance between your studio and your transmitting station. And secondly, whether there's a line of sight between your studio and the transmitting station, among other things. So let's go. Select the studio area, select the antenna height, select the transmitter area, which is the last transmitter site we created. Select the antenna height. Here, you're going to be careful because when we created this transmitter height, we used an 80-meter mast. But remember, the broadcast antennas will take maybe 10 to 20 meters of the mast top. So let's just say here that our antenna height is 60 meters because that's the zoom point where we'll hang our STL receiving antenna. So the description will be EMS point-to-point coverage study, and our frequency again is 98.3. Our transmitter power will be 15 watts. Let's leave every other thing as they are and click submit. Now the tool will compute. Yes, that is already done. Oh, we have a problem. As you can see here, we don't have a clear line of sight. Yes, look at this hill here. It's covering our signal. So to really achieve this, we will need to increase our antenna height. It's good this happens, so you know why we do this. So we'll have to go back again, new point-to-point link, select our transmitter area, let's leave this at 60. Select our transmitter area, we'll be looking at 120-meter mast this time around. Description still the same, frequency the same, transmitter power the same. Submit. Now we are slightly above that here. This will work, but in implementation, I suggest you do something around here. If it is possible, this mast here can be moved to this point here on this edge of the hair. Remember that you're supposed to do this before installation, so this is still at the stage when you're planning. So with what we know now, we can still even maintain our previous 25-meter antenna height here in the studio area and still leave our transmitter antenna height at 80 meters as it was, but then move the antenna, if we have that choice, to this point and this hill here, because this is where we have issues. So if this mast is moved to this point, then we won't have any other issues. Finally, what you then have to look out for is if there is any tall building between these 2 points. These are our details. This is the coordinate of the studio area, the ground elevation, our antenna height, the azimuth, the tilt. The same thing here with the transmitter sites. This is our transmitter power, transmitter line loss, and all the other parameters. This is also in propagation. This is what is happening in the space. Free space loss, obstruction loss, 0. Yes. I could have checked again. Okay, for the purpose of learning, let's see what obstruction loss will be. If we go back, let me add this to our links. You understand? But then, let's go to another new point-to-point link. Select the same locations. But now, let's leave this at 25. Let's select coverage study. That's our transmitter site. But this point, let's leave it at 80. Description still remains the same. Frequency, the same. Transmitter power, the same. So let's go back and see what happens. What will our obstruction line loss be? Because here we have an obstruction, so let's check. You see, we are losing 6.92 dB because of this obstruction here. You see, and that could affect the signal between the studio and the transmitter site. You can also see here urban loss 1.5 dB, statistical loss 6.37 dB, total path loss 109.68 dB, because we have free space loss at 94.94 dB. Distance is approximately 14 kilometers. And this is our study. Doing it now from Google Map. This is our transmitter site in Pape, if you remember. And this is our studio area. So this is it about coverage study, guys. I won't save this because we'll be using the other one. So we can still return back to here and then go to our point-to-point links. Select the one you want to view, which is this, and click view this link. So here, we do not have obstruction loss, we do not have forest loss, and our urban loss is just 1 dB. Statistical loss is about the same. And here we have total path loss at 102.33 dB, which is smaller compared to what we had on the previous one. So guys, thank you very much for watching. Hope this will help you plan better when next you're dealing with transmitter installation. Thank you again for watching.